All right. Next, I'm happy to welcome Fran Slater here from Opentrons. She's coming up, who is going to talk about their new system, but in general, what Opentrons does, which is open source automation. And we're happy to have her here. We're happy to have her as a sponsor as well. And she'll also be, or someone from her team, and probably herself too, will be at the reception after they've got us set up here as well. Welcome.
Yeah, thanks for having me and having us. I will just point out our two other members of the team, Songyan and Rami. They're in there. So we will be down in the other building, 610 Commonwealth Ave at 3 o'clock if you want to see this robot up close and personal. So yeah, thanks so much for inviting us. Thanks to Doug. It came out of a conversation a couple of months ago, but also comes out of like a long history of Opentrons and DAMP. So Doug's lab was one of the first people to have the OT1, which was our first robot. I think one of the first labs to have the OT2. And Courtney, Dave, and Rita were one of the first external people to touch the Flex about a month ago in our lab in New York. So yeah, we're really pleased to be here, and also really grateful that I followed Peaks. I think this really kind of, we're an open source robotics company, which is unusual. And so, you're speaking our language. Great. So I will go pretty quickly just because I don't have that much time. But if you don't know about Opentrons, we are an open source robotics company. We were founded in 2014 with the idea of doing liquid handling automation slightly differently. So we want to make liquid handling automation more accessible to more people. That means make it more affordable. That means make it available on a very small scale as well as a sort of a medium scale, and try to make it simple to use. I think that is a journey that we're all on still. And so I won't say that we've solved that problem, but it's definitely a principle that we kind of live by. Another fundamental part is that we're open source. All of our software and firmware is open source, and which offers sort of unlimited integration possibilities. We're also reagent and kit agnostic, and we integrate with a lot of other hardware as well. And finally, we try and build on the principle of being scalable. So you can buy everything as you need it. Everything is modular, different pipettes, different hardware. And today I'm here to talk about our new robot, which we launched just last month. It's the Opentrons Flex. We got rid of the numbering. We were OT1, OT2, and we sort of just jumped off that path, and now it's called Flex. So if you're familiar with the OT2, and if you tour the DAMP lab, you will see one. It's a small benchtop liquid handler. It fits in a biological safety cabinet, which is unusual. The Flex is a bit bigger, but it follows the same principles of being open source and scalable and so on, the same software ecosystem, and you can exchange some of the hardware modules between platforms. It is ideal for higher throughputs, though, and more complex workflows, which we'll talk about in a minute. Everything is modular, including the pipetting heads. You can sort pipetting heads out yourself in a matter of minutes. And we have brought in a 96-channel head and a gripper to increase throughput. So this is it. Yeah, I mentioned we have now a 96-channel pipette option. We have slightly more deck slots, so it still fits on a lab bench, but you can now do 96 samples of some things, which you really couldn't do with the OT2, at least not without a lot of manual intervention and tip swapping. So we managed to get away with 12 deck slots and 4 additional slots that are just for tips and labware to replace that the gripper can access, but the pipettes can't access. And that really gives you the ability to do 96 samples of quite a lot of stuff, including NGS library prep. There is also a little on-instrument display there, which allows you to kind of pull up your protocols and run them from the screen. And we offered kind of bundles for different applications like nucleic acid extraction and NGS. This is a little just on the on instrument display, which is a new feature compared to the OT2. So it will guide your deck setup. So once you have a protocol, it will tell you where to put things. You can easily pull up protocols that you've already written and rerun them from that screen. And probably the most exciting feature, at least for us, we set up a lot of robots, quite a lot of, spend a lot of time calibrating robots. This now has automated calibration. So the pipettes and gripper will do an automated positional calibration themselves. If you've ever tried to calibrate an OT2, you'll know it's a very manual process, and you really need quite a lot of expertise to know exactly how to do that. This is an idiot-proof process, as in that it does it all for you. We offer the same way to make protocols. So we still have the no-code protocol designer app. We have the Python API, which is our kind of preferred method. It's the most sophisticated option. We have an open source protocol library where we store, I think, about 500 or 600 protocols, some that we've written, some that our community have written, some that are verified by different reagent partners. And we also will write code for you if you want us to. These are pipettes. This is getting really into the weeds now, but we have made these pipettes are different to the OT2 pipettes. They have wider volume ranges, which is useful if you're trying to pipette different volumes, of course, and they go down to 1 microliter. This is our specs for the single channel pipette. We're pretty happy with our 1 microliter sort of accuracy and precision stats. We get sort of 8% in accuracy, 5% in precision. And these are the accessories that can all be kind of purchased a la carte. So there's the gripper, there's an on-deck thermocycler. This is, without question, the cheapest automated thermocycler you will ever see. There's also a temperature module, a heater shaker, and a magnetic block for bead cleanups. Okay, and now some data, which is probably the more interesting part. So I think this really fits in well with the pilot projects that we heard about before lunch, because these are, a lot of these applications are the ones that we like to test our systems with. So this is NGS library prep data. It's E. coli, I believe, and just DNA-seq data. And for us, like, CV is that's what we're looking for. We're looking for like great uniformity across samples. And so you can see here that the uniformity across these libraries is very good. I'm pretty happy with that. And the same thing when you look at protein purification. We see high uniformity across these different magnetic bead-based immunoprecipitation runs. And then finally, nucleic acid extraction. This is extraction from some HeLa cells. Again, the CV here is really great. Very little difference between the different samples. Okay, and then another thing that we like to do, which is again a little bit different to other automation companies, is we like to just tell you how much everything is going to cost. So our prices are on our website, and they really are our prices. There are no sort of shady discounts. So for a workstation, for an NGS workstation, which is essentially a fully spec'd out robot with pipettes and thermocycler and magnetic plates and temperature block and so on, you're looking at, for an 8-channel workstation, you're looking at $50K. And then if you want to do higher throughput and use the 96-channel pipette, you're looking at about $60K. I don't know how many quotes you've got for NGS workstations recently, but this is pretty cheap. This is pretty affordable compared to your average NGS workstation. We have similar workstations for extraction, for PCR setup and automated thermocycling, and for magnetic bead-based purification. And alternatively, you can buy the robot and pipettes and so on a la carte. So you can buy a robot and mix and match depending on what pipettes and modules that you want to. So yeah, this is just the NGS workstation in slightly more detail. We believe that for other kind of 24 sample throughput solutions, you're looking at about 80K up. And for 96 samples, you're looking at more than 100K for sure. Another point about flexibility, the clue is in the name. You're not locked into specific reagents and consumables except for tips. And again, you can write your protocols in a number of different ways. And that is it. We will be downstairs at 3 o'clock with the robot if you'd like to come and see it up close.
So it seems like there have been a lot of great improvements in DO22 and Nucleic. How do you think about prioritizing the next set of features for Flex 2 or Flex or whatever?
So I think the Flex, we really prioritized customer feedback, which was really sort of like, we love the OT2, but we wish it did XYZ. And, you know, people asked for a gripper and they asked for a 96 channel head. And we realized that the sweet spot in terms of throughput is not 96 plus, but it's also not 12 to 24, which is what the OT2 could do. So that's why we came up with the Flex. I think that in the future, we probably want to go, we want to make an even more affordable instrument. We've gone slightly upscale here, but that's not really our business model to make things more sophisticated and more expensive. So I suspect that the next generation will be another attempt at making it even more accessible, even smaller potentially.
You read my mind there with the second question. I think this looks like a really cool platform. But I do remember that early vision of this sub whatever number robot. You prepped up a little bit. It makes sense for this platform. So you've answered my second question, which is you're going to be probably making different models that are down in price potentially.
I think so.
Or sophistication. But the question I had, if I bought a 3D printer, my understanding is if I buy one, I go to like the Thingiverse. There's a place where I can get all these gadgets. I can try it out. And so I make sure the answer to this. Is there an ecosystem like that being developed in your space of the world where these are all the open source liquid handling scripts and tests? Has the community started to do that? Because I can imagine that being interesting.
So yeah, I mean, our protocol library at the moment has probably 50-50 our scripts and 50% other people's scripts in it. It is at the moment you have to go through us to get your protocol on there. So we host community scripts, but you have to email us and it's a little bit involved. We will be launching a new version of the protocol library at the end of the summer where we will let people upload their own script, and it will be a more seamless process, right? You have a script that you want to share with the community and it's written in Python or it can be a JSON protocol designer file. You can put it on our library yourself without having to kind of go through our team. So at the end of the summer, it will be a lot easier to do that. It will also be will improve the searchability. If you've looked at our protocol library, it's all there, but it's all kind of it's not easily searchable. So it will be better at the end of the summer.
And just to say something out loud, I can imagine somebody sees this and says, "Oh, I love the Flex, but I'm this high school student. I don't have the money to buy a Flex. I go to this place, I go to this repository of this app store, if you will, of protocol. You click on the protocol. One is to download it on your robot, or maybe when you click on your cloud.
Yeah.
So you run it at an Opentrons somewhere else, and that's something that we could be talking about over the days with all the folks.
Yeah.
What would it mean if you don't have access to a robot? Could you run that remotely at one of these facilities?
Absolutely. And I think that there's a huge continuum there, right? Because automation, even Opentrons automation, is a huge investment, right? Not just the money, but also the skills and the learning curve and just the transition of methods and so on. And having a service option, which is maybe the first step and maybe on a longer journey towards at some point, when you scale, you bring automation in-house. Having a service option is is the ideal way to make that journey to automation more seamless, for sure.
Thank you, and we'll see you at 3.
Yes.